Okay, so let's focus here on section 8.1 of the hypothesis testing chapter. Okay, so this will cover the basic principle of hypothesis testing. First thing that we need to understand is when we do hypothesis testing, we are always testing between two hypotheses. So whenever you have a problem, we'll have to state both hypotheses. The first hypothesis is called the null hypothesis, okay? So basically the idea behind the null hypothesis is that you have a population parameter, the population mean or the population proportion if you have a qualitative variable. But you are not sure whether this is actually the right information, the right parameter. Okay, so this is the basic idea of a hypothesis testing problem. So in the null hypothesis, you are stating, yes, the population mean of or the population parameter was correct. It was the right value. Okay, so basically the mean of the population equals the value that is given to us. Okay, so if we're looking at the null hypothesis, the symbol that we will use is HO. So remember, when we state HO, there's always an equal sign included in there. Okay? Whereas for the alternative hypothesis, the second type of hypothesis, the parameter, so we're saying that the value, whether it's a mean or a proportion that was given to us, is actually not the real value. So it's not equal. So it could be greater, it could be smaller, or if we don't know which way it will go, we could just state that it won't be equal to. Okay, so I'll show you an example in a sec. So the symbol or the notation for the alternative hypothesis is HA. Okay, so that's what we use. If we are focusing a little bit more on HA, okay, so the alternative hypothesis, which by the way, in your textbook, you will see H1. H1 is the same thing as HA, it's the alternative hypotheses. So there are three possible types of alternative hypotheses, and I mentioned them quickly in my last slides. Okay, so the first type of alternative hypothesis could be what we call the left tail test. So basically what we're saying is that the mean or proportion that was given to us is actually, or not that was given to us, but the true mean and the proportion is actually smaller than the value that was given to us. Okay, so that the actual, the true, the reality is smaller than the value given to us. We could also have a right tail test. And what we're saying is the actual, the reality, the real value, which is a mean or proportion, is greater than what we thought it was, than the given value. Okay, so that's the right tail test, and that's the sign, the greater than sign associated with a right tail test. Okay, and finally, we could have a two tail test. In the two tail test, we're just saying that we're testing the claim that the reality is that it's not the same value as it was given to us, but we don't know if it will go up or down. So it's actually not equal to. Okay, not equal to. Okay, so let's try to practice and apply this a little bit. So I'm going to give you three examples here, three practice problems. And what I want you to do with the very limited information you have, as well as your textbook, I want you to try to solve this. Okay, and I'll show you the steps, I'll show you how to get there, but I just want you to state the null and the alternative hypotheses. Okay, so write HO, write HA with the right sign and the right information. Okay, so let's try to do this. I'll give you three problems and then I'll solve them with you. So for the first problem, Nissan claims that the Leaf, an electric car, has a mean range of 110 miles between charges. So that's a population mean. A consumer group claims that the mean range is less than 110, so that it's not actually the value. Okay, so let's set the null and the alternative hypotheses. Problem number 2. The Ohio Department of Health claims that the average stay in Ohio hospitals after childbirth is greater than the national mean of 2 days. So right now you have all the information to set the null and the alternative hypotheses. And problem number 3. A wildlife biologist in an African savanna claims that the actual proportions of female, so the word proportion here refers to a qualitative variable. So the actual proportions of female zebras in the region is different from the accepted proportion, the population proportion, of 50%. Let's try to solve these problems here. Okay, so write your answers down and then I'll show you the answer in a sec. Okay, so if we're looking at our first problem here, we had Nissan claims that the Leaf, an electric car, has a mean range. Okay, so our mean range, this is our population parameter. Okay, so there you go, population parameter of 110. So this is a mean. Okay, so we were testing the claim that the mean range is less. So if we are setting our null hypothesis, HO, we're always saying that the value was right, so that the population mean is in fact what was given to us. Okay, 110 miles. Versus HA, we are testing the claim that this value should actually be less than 110 miles. Okay, so there you go. So that's for the first problem. For the second problem, the value that was given to us was 2 days. Okay, so in terms of stays at hospital. So for my null hypothesis, I'm testing the claim that this is the right value. So that the population mean, because that's a mean, is equal to 2 days. Okay, whereas they are asking me in the problem, test the claim that it's actually greater than the national mean of 2 days. So I'm actually testing whether the population mean is in fact greater than 2 days. Okay, so here the first problem we have a left tail test. The second problem we had a right tail test because of our little sign that we have here. And for a third problem, they're talking about a proportion, and a proportion, which is P, of 50%. Okay, so what we need to remember is any kind of proportion we always write in a decimal form, so 0.5. So for our null hypothesis, we're testing the claim that this proportion is actually the right value. So we're saying that P is in fact equal to 0.5. That's our HO. Whereas for HA, we're testing the claim that the population of female zebra in the region is different than 50%. So we don't know if it's greater or smaller, but we're testing the claim that it's not equal to 0.5, that it's different. And this is how we set the hypotheses. The last problem is a two-tailed test because I have a not equal to sign. Okay, only 2 more slides for this. So first of all, possible conclusions when we do hypothesis testing. So at the end of all the steps, and by the way, those steps we'll learn in class. At the end of all the steps, we have 2 options to choose from. Okay, so 2 possible conclusions. And note that the options are always around HO. So our conclusion will always involve HO, will never involve HA, so the alternative hypotheses. So your first conclusion could be, I decide to reject HO because the numbers say so. Okay, I have support. I know that I should reject HO. In other words, the alternative hypothesis has support, but my conclusion is I reject HO. Okay, so the conclusion is always around HO. So that's one possible conclusion. The other possible conclusion, I do not reject HO. I fail to reject HO. So in other words, what this means is that the alternative hypothesis does not have support. So I fail to reject HO. It means I retain HO. But that's not the right language. I have to use fail to reject. If I fail to reject HO, HA is not true, does not have support. Okay? Last thing, when we make conclusion, it is possible, because we are working with samples, that we are actually making the wrong conclusion. And this is called type 1 or type 2 errors. Okay? So this is a table in your textbook. There are 2 possible types of error. Okay? Like I said, type 1 and type 2. So let's try to make sense of it. On your left, you can see decision. Okay, so this is basically the conclusion that we just talked about. Reject HO or fail to reject or don't reject HO. And if you're looking at the top, you see the word reality. Okay, so the reality, the actual truth of your experiment. So in reality, HO could be true or HO, so the null hypothesis, could be false. Okay, if your decision is to reject HO because the numbers say so, and in fact, HO was false, then you made the right decision. You can see this in the corner there, okay? But if you decide to reject HO when in fact, okay, HO was true, you made a type 1 error. Okay, so you rejected HO, you said HO is not true, but HO was true, type 1 error. Whereas if any of your decisions involve not rejecting HO, so you're thinking HO is actually true, so I won't reject it. And in fact, HO is true. Look at that, you have made the correct decision. So no mistake there. But if you're saying you decided that HO was true, so you did not reject it, and in fact HO was false, you made a type 2 error. Okay, so in fact, HA, the alternative hypothesis, had support, and you thought that HO was true. That's a type 2 error. Okay, so this is all we need to know about type 2 error. Remember that you always have to state two hypotheses, and your conclusion is always around HO. Okay, more to come in class. I'll see you soon.